heard of the term almost locked set or ALS, but don't know what that is or how you can use it in a Sudoku puzzle? Greetings, friend. In this video, I will break down this advanced Sudoku strategy, including all the definitions you need to know, plus show you expert tips and tricks on how to use ALSs to solve hard Sudoku puzzles. And with that, it's solving time. Okay, this puzzle may seem a little familiar to you. For example 1, this is Mark Goodliff versus Classic Sudoku. And I wanted to show you something familiar and kind of get you used to this ALS almost locked set concept. So first, we got to do some definitions here, right? If you want to understand what an almost locked set is, you kind of need to know what a locked set is. So a locked set is when the number of possible candidates equals the number of cells that the candidates are in. So right here, you can see 5, 8, 5, 8. 2 candidates, 5 and 8, 2 cells. All right, that's a naked pair. It's a locked set. Pretty simple, right? Same thing here with the 2, 6, 7. You know, that's a naked triple, right? 2, 6, and 7 are limited to those 3 spots. You can also go down here and look at this 4, 8, 9, because it doesn't. You don't need all the candidates in each cell. You just need, those 3 candidates, 4, 8, 9, are limited to those 3 cells in that house, right? So locked candidates refer to same number of candidates, available candidates for the same number of cells in a house. A house is any Sudoku row, column, or block. Okay, that's important. That's a locked set. So let's think about an almost locked set. Well, as the name implies, it's like a locked set, but it's not quite. So an almost locked set is when you have one more candidate for the amount of available cells, right? So if you have the simplest almost locked set is a single cell. So if you look right here, you'll notice there's 2 possibilities, 2 candidates in this one cell, right? This is row 6, column 9. 2 and a 7 are the available candidates. So you have this number of cells, 1, plus an additional candidate, 2. So 2 candidates in one cell is an almost locked set. This is the smallest almost locked set that we can find. Now, we can expand that out. Let's find another cell in that house that shares candidates, but now there's going to be 3 available candidates in the 2 cells. So you see here, it's still in the same house, and now you have 2 cells, and there's 3 different candidates. 2, 7, and 8 are the possibilities for these 3 cells. So that is an almost locked set. Okay, and you can expand it a little bit more. We could add on this, and now you see 2, 5, 7, 8, 4 candidates in 3 cells, another almost locked set. And so you can just keep on growing until you can get to 8 cells with 9 possible candidates. That's the biggest almost locked set you're going to get, right? You probably noticed there's a ton of those throughout this puzzle. I mean, you could go, right here and see, 1, 2, 7, and 8. 1, 2, 7, and 8. That's an almost locked set, and you can just keep going. You could do 1, 7, 8, 1, 7, and the 7, 8 there. 1, 7, 8. So there's actually estimated there's hundreds of these, but not all of them are valuable or useful, right? And so this is where we play into how can we use the thought of an almost locked set to create some eliminations. That's what we want to do. We want to make some eliminations. We want to solve a puzzle. Well, what you have to do is you have to compare 2 of these almost locked sets, and then they have to have some kind of relationship that allows you to make an elimination. Okay, one of the simplest paired almost locked set that we can put together is an XYZ-Wing. Okay, and so I'm going to show you, this is why I picked this puzzle, because there's an XYZ-Wing that Mark had solved in this puzzle. And this was the XYZ-Wing. If you remember, an XYZ-Wing is when you have 3 candidates, 3 different cells, so 2, 7, and 8. One of the cells is a pivot, and it sees the other 2. And then each of those, each contains 2 of the 3 candidates. So there's a 7, 8 here, 2, 7 there, different pairs. And they all have 1 candidate in common. And so by using XYZ-Wing, we know that we can eliminate the candidate 7 from any cell that sees all 3 of these colored cells. So you can eliminate a 7 from right there. That's applying the XYZ-Wing logic. Well, believe it or not, an XYZ-Wing is an almost, it's made up of 2 almost locked sets. The first one's in purple, so 2 candidates and 1 cell. The other one's here in orange, so 3 candidates and 2 cells. And the way you make the elimination is by applying almost locked set XZ rule. And don't worry, I'm going to break this down. It's going to make it nice and easy for you. Okay, so an almost locked set XZ rule is that where you're comparing 2 of these so you can make an elimination. And this XYZ-Wing is a type 1. And type 1 means that it has 1 candidate in common that helps us make an elimination. The type 2 is when you have 2 candidates in the 2 almost locked sets. And I'll cover that in a future video. Today we're just going to focus on ALS-XZ type 1. All right? And there's a whole new world I'm exposing you to here, but I'm going to make it easy for you and I'm going to help you out. So here's how the XZ rule works. What you have to have is you have to have a candidate that's shared between the 2 almost locked sets that can see all instances of that candidate. That is called the restricted common candidate, RCC. So what you'll notice of the 2, 7, 8, which candidate is in the purple and in the orange, and it sees all instances of itself. Well, it's not the 2 because the 2 is just in the orange. It's not the 7 because this 7 doesn't actually see that 7. It's the 8, right? So this 8 is restricted common candidate. And that's good to know. And then for the, and that's what we call the X candidate, all right? The X is that restricted common candidate. It's not the candidate we're going to use to make the eliminations. What we're going to use to make the eliminations is another common candidate, and then the other common candidate is the one that you can eliminate any candidate that sees all 3 of that other common candidate. So the other common candidate is the 7, right? Because there's a 7 in here and there's a 7 there. And so you see this 7, and this 7 all see the 7 right here. So we can eliminate that 7. So remember, when we did the XYZ-Wing, we were able to eliminate that 7. Well, now using almost locked sets, we have a restricted common candidate right here, the 8. So that means these sets have restricted common. And then we have this other common candidate, the 7. And so now you can make an elimination whenever that common candidate, the Z candidate, sees. Boom. So it still works the same way. All right, hopefully that's pretty cool to you. There's not any videos. Now, this is like the first video talking about it. Swami talked about making a video about almost locked sets. He hasn't made new videos since he did his initial series. And so this is probably the first one you're going to see. The only other way you can find this, and I'll put some links in the description below, is going on and looking at forums and reading through it and looking at the diagrams. And that's what I've done for you. Philip Newman talks about almost locked sets a little bit in the Sudoku discussion, but it's not the purpose of the videos where he talks about it. And I'll put a link to that one when I cover the type 2s, because that's the one he's really talking about. All right, so this is how the XZ works. Now, if you're pretty astute and pretty familiar here, you might notice that you can actually create a different almost locked set here, and it'd still be valid and still get all of the eliminations you wanted to see. And what you could do is you can make that one set, and you can make this the other one. Right? This is 2 cells with 3 candidates. This is 1 cell with 2 candidates. They have a common, restricted common candidate. In this case, it's the 2, right? The 2's here, 2's there. All the 2's, instances of 2 in these 2 sets see each other. And they also have a common candidate, the 7. And you'd make the same elimination. So you see how the 8's, instead of the 8's being the restricted common candidate, if you did it this way, it's the 2's. But you still make the same elimination. So either way you slice or dice that, almost locked set, same elimination. So that's how the almost locked set XZ rule works. Okay, you heard me talk about all this. You're like, well, Timberlake, how do you know it works, right? How do you validate these things? And the reason it works, and why I'm going through all this, and the magic of the almost locked set, the idea is that you cannot eliminate a 7 and the 2 from these 3 cells. Because if you eliminated the 2s, which is that restricted common candidate, and you eliminated the 7s, well, you could put an 8 in one of these spots, like maybe here, but then you'd have nothing to fill there, right? You would run out of candidates. So when you have those 2 candidates and you only have 1 extra candidate, you need at least one of those 2 candidates. That's kind of what the rule's saying. Another way to put it is, if you put the 7 here, what would happen? Because that's that elimination, right? You put a 7 right here, you'll see what happens pretty quickly. Well, I can solve that for an 8. I can solve that for a 2, but the 2 and the 7 are right here. Can't solve that for anything. So you break the puzzle. So we're working backwards by finding that common candidate, going, okay, I can make that elimination. Because if you don't make the elimination, here's what happens. And I'd tell you that when people are doing bifurcating and they kind of go through and say, okay, if I try 7 here, what happens? Or if I try 7 here, what happens? Or 5 here, what happens? And they go through and they break the puzzle. They probably ran into some form of an almost locked set, and they probably eliminated one of the common candidates. See? You see how it's all starting to come together? Okay. Something else you may notice is, if this happened to be just a 2 and an 8, and this was an XY-Wing, you could still look at it as an ALS, but XY-Wings are a little bit easier just to see the way they are. It's probably overcomplicating things. I wanted to use this XYZ-Wing to kind of reinforce some of these concepts we're talking about here, and kind of get away from an XY chain type scenario. All right, let's move on to our next example. Okay, for the next example, I just created a random Sudoku out of Hodoku, and I wanted it to show an XYZ-Wing. So there's an XYZ-Wing in this puzzle at the stage that we are in the solving process. Can you find it? And this is something I probably didn't cover enough, and I want to kind of elaborate a little more on my XYZ-Wing tutorial. How do you find these things, right? Because one of the problems at Almost Locked Sets, when you have hundreds to choose from, is how do you zone in and find these things? Well, I can tell you the key with the XYZ-Wing is you want to start and you want to look at 2 things. One is the by value candidates, and the other is the triple. So an XYZ-Wing, the pivot has to be a triple. It's got to have 3 candidates in it. So I'm going to show up all the by value cells. That's what the greens are. And then we're going to start looking through here, right? So look right here. I have, what are the triple candidates in here for the pivot? 2, 5, 6. So in order for this to work, I would need to have either 2, 5, 2, 6, or 5, 6 within this block, and then reach out. So you can see there's a 2, 6 down here, but I would need a 2, 5, or 5, 6 within this block. And that's a 5, 9, 6, 8. So this is not a good candidate. There's no other triples inside block 1. Go to block 2, you have a 6, 8, 9. You have a 6, 8. Okay, that's good. This is within the cell. This is a triple. So now you would need a 6, 9 or an 8, 9 that sees this cell and it's outside of the block. So is there a 6, 9 or an 8, 9 out here? Nope. And you go over this way? Nope. So this is not valid. There's no other triples here. There's no triples in block 3. You go to block 4, there's no triples. Block 5, you have a triple, and you have a 6, 7, and 2, 6, but they're both within the same block. And then you can see here, here's a triple here with a 6, 7, and a 6, 7, but that doesn't work. They got to be 2 different by value cells, and you can see this 2, 6, 6, 7, 2, 6, 7. This is just a naked triple because it's all in the same house. It doesn't see this 2, 7, doesn't see this triple. So basically I'm saying it's not working. And with this 2, 6, you need this 6, 7 to be outside of the block. It's not outside the block. So you can see why this doesn't work, right? Go in here, there's no triples in block 6. Let's go to block 7. All right, block 7. There's a 3, 5, 6. And you can look up and you can see there's no by value cells here. There's a 3, 6 outside, but there's nothing inside 3, 5 or 5, 6 inside to help you make triple. Same thing here. But let's go to this 5, 8, 9. All right, it's a triple. And we'll mark it. There's an 8, 9 right there. So that's a by value cell. Awesome. And then let's look up outside the block. Is there another by value cell related to 5, 8, 9? So we need something that has a 5, 8 or a 5, 9. And sure enough, you come up here and you see There's a 5, 9. All right, and so the other important piece of an XYZ wing is, does it create any eliminations? And so to create eliminations, you need, what's the common candidate? A 9. Does it all see a cell with a 9 that we can make an elimination? And it sure does, right? 9, 9, 9, all look at this cell right here. And so by XYZ wing, we can eliminate that as a 9, right? So this is kind of like how I go through and try to find XYZ wings. I'll look for them after I'm done looking through the normal just by-value cells, looking for XY wings, you know, and then XY chains, right? I start focusing on those. But you basically have to see these two, find a pivot, good to go. Now, what I also wanted to show is this, of course, could be solved using Almost Locked Set. So let's now create the coloring, right? Make an Almost Locked Set. So you can see right here, we have 2 cells, 3 candidates, 5, 8, and 9. Now we need to look up, and can we find some other cell that has a common candidate with the 5? And for the restricted common candidates, it's helpful if in this Almost Locked Set, if you just see it once, like the least amount of 5s you have, the better it's going to be, because you're just trying to connect one of those. They have to all see each other. So you come up here and go, yep, that's a 5. And then you go, well, does it have a common candidate? So this has a 9, and these have 9s. And does that common candidate create an elimination? And sure enough, it does, right? So this is an Almost Locked Set. This is an Almost Locked Set. It has a restricted common candidate of a 5, which is our X candidate. And it has another common candidate, a 9, which is our Z candidate, and then we can eliminate a 9 from any cell that sees all 3 of these. So you can eliminate a 9 from right there. And like I've proven in the previous one, the reason why is if you put a 9 right there, then you have a 5, 8, an 8, and a 5, and you would run out of places to put all this, right? So you have an 8, a 5, and nothing to put right there. Bad stuff. But let's go the other way. Since the 5 is that restricted common candidate, what would happen if you put a 5 right there? I mean, you'd still be able to solve okay. The restricted common candidate is the one that basically has to be in one of those two, right, for it to work. But if you put a 5 right there, this is an 8-9 pair, that's a 9, 8, 9. It could work. So that's why you're not eliminating the 5. Now, there's a time when you can use the restricted common candidate, make the limit. If the restricted common candidate would be within this block, then you can eliminate the other 5s within the block. It's not the case for this puzzle, but I'll cover that in a later video. In this case, since they're in different blocks, you can't eliminate the 5, but you can eliminate the 9, the common candidate. Okay, before I move on, real quick, I have found out that I have more returning viewers to my channel than I have subscribers. That means there's people who are really enjoying this content, but you haven't subscribed, and so you're not getting the latest updates and features. Please consider subscribing to my channel. It does 2 things. 1, make sure you don't miss any of my new videos. It comes out on Tuesdays, Fridays, and Sundays. And 2, the more people that subscribe and the more feedback and the comments that I get, the bigger footprint I have on YouTube. And now I can share this content with more people like you who want to transform that passive interest in Sudoku to a fun and enjoyable hobby. So you're helping me get these videos out to more people that would enjoy it. And it encourages me to keep making this great content for you. Thanks. All right, let's move on to our next example. We're going to cover something else that you might be familiar with that's also an Almost Locked Set. Okay, this example 3 may be a little familiar to you. It's something I've used in a couple of my previous tutorials, and I've done an analysis video on it. This is from Cracking the Cryptic. This was Simon solving a puzzle from the UK Telegraph, and he found a WXYZ-Wing. Guess what? A WXYZ-Wing, which I've covered in previous tutorials, and I'll put a link to that right now if you're not. Actually, I'll put a link at the end of this video so you can go check that out if you're not too familiar. Is a type of ALS, and you apply the Almost Locked Set XYZ-Wing to solve it. In fact, if you're on Hodoku, which is what I'm using to make this video, that app, you can't just plug in WXYZ-Wing to practice. You have to put in and study ALS-XZ Wings, and about every 9 or 10 of them that show up, one of every 9 or 10 will be a WXYZ Wing. The other ones will be a little bit more complicated. And those more complicated type ones I will be covering in my next video. So let's go right here and help familiarize you with the WXYZ Wing content. What you need, if you remember WXYZ Wing, you need 4 candidates that are in 4 different cells. All right? You need a spouse, I call it, which I'll put right here. You need a I'm sorry, I said spouse. Parent. You need a parent. This is the one that sees all the other cells. You need a spouse. And the spouse shares it's going to be a bi-value cell, has to be a bi-value cell. It shares one candidate with the parent, and it shares another candidate. It's called a restricted candidate. And guess what? Restricted candidate, it's going to be real similar to what we have with our ALSs, right? Then you got the children, they call them. And so these are 2 cells that see the parent, and they have that restricted candidate that's also in the spouse cell, and that's how you make the eliminations. Basically, you're going to be able to eliminate a 1 from any cell that sees both of these ones. Cool, huh? All right, so let's change up the coloring a little bit. And this is how the XYZ, if you want to validate, you basically plug in all the values right here, and you'll notice that a 1 either has to be here or here, and so you can end up eliminating this 1 right there. But eliminate the colors, and so let's show this now as an almost locked set and apply the XZ rule. You'll notice is we have one house right here, right? So one of the ALSs has to be in one house, and we'll do that. And then the other ALS has to be in its own house. And so what you can always do to change a WXYZ-Wing into an ALS-XZ is just make that spouse cell, you just make the spouse cell its own ALS, right? Because if it was in line with these, and then it would be a naked quad. It's not in line, so it has to be off. So, do we have, you look at column 5, the 3 in purple, there's 4 candidates and 3 cells. 1, 2, 3, and 6, 3 cells, that's an almost locked set. You look right here at the orange cell, almost locked set. 2 candidates, 1 cell. So that part applies. Now, does it have a restricted common candidate? You'll notice, is there a candidate in the orange that sees in the purple and they all see each other? Yes, it's the 2. So the restricted common candidate for purposes of an ALS-XZ rule is the 2, right? The 2s all see each other. Great. Now, is there another common candidate that where we can make some eliminations? And sure enough, the Z candidate is actually this 1. Remember, these don't have to see each other. They just have to be able to see something else you can make an elimination, right? And they have to be in both the ALSs. The other thing I wanted to point out is restricted common candidate. You can have more than one of those as long as they all see each other. So that's why I wanted to show this example. So knowing that there's a 1 here and a 1 there, that's a Z candidate, you can eliminate a 1 from any cell that sees both of those. So you can eliminate a 1 from right there. That has to be a 7. And if you want to go backwards, what would happen if you put a 1 right there? If you put a 1 right there, that's a 6, that's a 2, that's a 3, and that has nothing. So that's why. And so that's why we do all that, go, okay, almost locked set, we can eliminate that candidate, and you move on. And so all I'm showing you about the XZ rule is you're doing a solving method. You're not doing a bifurcation where you stick in the 1 and break the puzzle. That's just validation. You're doing the solving method to go in here and go, okay, the 2s are all aligned here, the 1s are there, I can eliminate this 1. And then you move on, right? Hopefully this is making sense that I'm showing you how to solve the puzzle logically using WXYZ-Wing. Okay, let's move on to our next example. All right, so for the last example, I picked probably my favorite puzzle of all time, Timberlake by Bondye. It's named after me. We're at this diagram, and we're going to be searching for almost locked set type ones where we can apply that XZ rule. So how would you do it? And I'm not going to mess around. It is hard to find almost locked sets. I can tell you the one that's here that you'll find, there's actually two. They are WXYZ-Wings. So what would I do to kind of work my way around and try to start finding these things? Well, the best thing to do is look for buy value cells and see if there's something you can do with the buy value cells. Now, if you have a naked pair, almost locked set's never going to have a naked pair because this is a locked set. It's not going to help you out. So you can get rid of that, you can get rid of that, you can get rid of that. So we're not worried about those. This 1, 4, you can look down here, 1, 2, 4, 5 is there. Does it point out anywhere immediately? Nope, it doesn't. So that 1, 4 is not helping us. 3, 9, so you got a 3, 4, 9. Does this, with a 1, is there a 1 up here? Nope, there's no good spouse cell, so this 3, 9 is not helping us. We already eliminated all those. There's no buy value cells in here to even consider. The 6, 9, we can kind of look at, and we'll come back to this one because there is something you can do with this 6, 9, and I'll get to that. But first, I want to come down here. You'll notice there's a 2, 4, and a 2, 9, and you'll notice there's a lot of like 3, 4s, 9s working here in block 5 and down here at block 8. And so let's focus on this cell right here. Okay, they got the 2, 9, all right, and I got a 2, 3, 4. Okay, so I got 2, 3, 4, 3, 4, 9, 3, 4, 9. So what you'll see here is that's an almost locked set, right? So first thing you're looking for, an ALS that has 1 to 2 candidates restricted to 2 houses. So you'll notice is this 2 is restricted to just 1 house right there. And then these 9s are restricted to just this house. The 3s and 4s are not. But this is a pretty good ALS to look at and consider. Then try to identify a second almost locked set that has a restricted common candidate to the first. So if you come over here and go, oh, well, this 2 and this 2 are restricted common candidates. They are in the same block, and they both see each other. Awesome. So that's the second thing about identifying a valid ALS-XZ for eliminations. And then 3, check for another common candidate where eliminations can be made. So what does this cell have in common with this cell, or with this set? 9s, right? So you got 9s here, and you got a 9 there. So that's a common candidate. Can we make any eliminations with that? And sure enough, these 9s and this 9, they all see that 9 right there and this 9 right there. So your Z candidate is a 9. And so you'll notice this is a WXYZ-Wing. It's the first one I found in this puzzle. And it's almost, 2 almost locked sets, 1 in purple, 1 in orange. It creates a valid elimination. We can eliminate the 9 from right there and right there. And I can go through it. If you put in a 9, you'll see that you'll end up running out of candidates. We need to work with both that 9 and that 2 for this to work, right? Got it. Hopefully you saw that. So that's kind of a way you can go through and find these, right? Looking for those WXYZ-Wings. Now let's look for the other one. And it focuses on this 6, 9 candidate right here, and then we can kind of like stretch it out a little bit. So we got to focus. We got a 6, 9 here. You got a 4, 6, 9 here. And so does this, this in itself is an almost locked set, but doesn't really attach to anything else where we can make any eliminations. But if you add in this third cell, now you have a 3, 4, 6, 9. You notice the 6s are restricted to this block. The 4s are restricted to this block. The 9s roll in here. And the 3, there's just one 3. So if this 3 can see another 3, maybe outside of this block, we can start looking for 2 ALSs for this XZ rule. And sure enough, you come down here and you go, oh, well, it sees this for 3. It's a buy value cell, so that means that's an almost locked set. This is an almost locked set. Well, let's evaluate this, right? Okay. So, the 3s are a restricted common candidate. They only see each other, right? So that's our X candidate. And then, is there another common candidate between these two where they all see some other candidate where we can make an elimination? And sure enough, you got 9, 9, 9, 9. Where are they all looking at? They all look at this cell right here. Is there a 9 in that cell? There sure is. So can we eliminate the 9 from right there? We sure can. Because the 9s are our Z candidate. So this was the second WXYZ wing. And hopefully I'm kind of showing you a way to kind of find these in puzzles. And it's not going to be that easy. But if you start looking at value candidates and start evaluating what can you do with them, can I find a restricted common candidate with another almost locked set, you'll start opening those possibilities up. So in my next video, I'm going to start looking at these type 1 almost locked sets that are not something common that you're used to, but they'll still create almost locked sets that we can make some eliminations using an XZ rule. Do you need a refresher on XYZ wings or WXYZ wings? Check out these other tutorial videos from my channel. If you want to further support Smart Hobbies by buying me a coffee, click the link in the description below. I'd really appreciate it. Thank you so much for watching.